Good morning, students. Let us see first inverse trigonometric function. That is sine inverse, cos inverse, tan inverse, quat inverse, sec inverse, cosec inverse. Isn't it? In this topic, we are going to see the problems like find the in this topic we are going to solve the sums like find the principal value of the sine inverse 1 by 2, cosec inverse 2, tan inverse of minus 1, tan inverse of minus root 3, like this, isn't it? For solving such type of problem, we must learn the principal value branch of sine in all trigonometric function. The table is given in a book that we have to must keep in mind, or that we have to learn by heart, that table. Using that table we can solve the problem based on trigonometric function. Let us see first table, that is inverse trigonometric function, then range, then principal branch value. This is also called as domain, isn't it? Now first is sine inverse x. We know that the values of sine function lies between -1 to 1, isn't it? Therefore range of sine inverse is -1 to 1, and domain domain of this function or principal branch value of sine inverse function is close interval minus pi by 2 to pi by 2. Means the values of sine inverse of some angle always lies between minus pi by 2 to pi by 2, and minus pi by 2 and pi by 2 are also included because close interval is there. Cos inverse, we know the values of cos theta lies between -1 to 1 and principal branch value of cos inverse is close interval 0 to pi. Means the value of cos inverse is lies between 0 to pi. 0 and pi are included. Third, tan inverse, the range of this function all real value. We can get the value of tan theta. And principal branch value of tan inverse is open interval minus pi by 2 to pi by 2. Here minus pi by 2 and pi by 2 does not belongs to the value of tan inverse because open interval is there. Then next function is quat inverse. Quat theta's value lies between all real values, and principal branch value of quat inverse is open interval 0 to pi. Means values of cot inverse are lies between 0 to pi. Means pi means 180 degree. Now next is sec inverse. Here the value of sec theta is all real values except the values between -1 to 1. These values are not for sec theta, -1 to 1. Remaining all real values are for the value of sec theta. And principal branch value of sec inverse is close interval 0 to 0 to pi minus pi by 2. Means the value pi by 2 does not belong to the value principal value of sec inverse. And last one is cosec inverse. Values of cosec theta are all real numbers except -1 to 1, open interval -1 to 1. And principal branch value of cosec inverse is minus pi by 2 to pi by 2 minus 0. 0 does not belong to the value of cosec inverse of some angle or some value. This is very important for that. You must learn this. Sin inverse, principal branch value, close interval minus pi by 2 to pi by 2. Cos inverse, principal branch value 0 to pi. Tan inverse, principal branch value, open interval minus pi by 2 to pi. Cot inverse, principal branch value 0, open interval 0 to pi. Sec inverse, principal branch value, close interval 0 to pi minus pi by 2. Means pi by 2 does not belongs to the principal branch value of sec inverse. Only 0 to pi means 0 to 180, but 90 degree will not belongs to the value of principal branch value of sec inverse. Cosec inverse principal branch values are minus pi by 2 to pi by 2, but 0 does not belong to the principal branch value of cosec inverse. So this table is very important. You learn this table. Learn this table by heart, isn't it? Now we will see the properties of inverse trigonometric function. First one, sin inverse of x can be written as cosec inverse of 1 upon x and minus 1 is less than or equal to x is less than or equal to 1 and x is not equal to 0. Second, cos inverse of x can be written as sec inverse of 1 upon x. Values of x are -1 is less than or equal to x is less than or equal to 1 and x is not equal to 0. Third, tan inverse of x can be written as quat inverse of 1 upon x if x is greater than 0. And fourth is important, tan inverse of x can be written as minus pi plus quat inverse of 1 upon x if x is less than 0. X is negative. Less than 0 means if x is negative, we have to write tan inverse of x is equal to minus pi plus quat inverse of 1 upon x. Isn't it? we can reverse this, isn't it? That is quat inverse of 1 upon x can be written as pi plus tan inverse of x. Transfer this pi to the left side, you will get this, isn't it? Also, now again 1. Sine inverse of minus x is equal to minus sine inverse of x. Minus 1 is less than or equal to x is less than or equal to 1. Second, cos inverse of minus x is equal to pi minus cos inverse of x. Minus 1 is less than or equal to x is less than or equal to 1. Third, tan inverse of minus x is equal to, we can write minus tan inverse of x. Fourth, quat inverse of minus x can be written as pi minus quat inverse of x for all x belongs to R. Sec inverse of minus x can be written as pi minus sec inverse of x mod of x is greater than or equal to 1. And sixth one, cosec inverse of minus x can be written as minus cosec inverse of x mod of x is greater than or equal to 1. So have a glance on these properties. While solving the problem, we will use these properties, isn't it? So keep in mind these properties are also, isn't it? Next formulas or next equations which are useful for while solving the problems are, first one is sine inverse of x plus cos inverse of x is equal to pi by 2. Minus 1 is less than or equal to x is less than or equal to 1. Second, tan inverse of x plus quat inverse of x is equal to pi by 2 for all x belongs to R, means real number. Third, sec inverse of x plus cosec inverse of x is equal to pi by 2 mod of x, means x lies between plus 1 to minus 1 is greater than or 1. These are useful formulae. Now fourth formula is tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. Here the condition is x is greater than 0, y is greater than 0 and xy product is less than 1. Next formula is fifth one. Tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y upon 1 minus xy. Here condition is x is greater than 0, y is greater than 0 and xy is also greater than 1. And sixth one, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y upon 1 plus xy. Here condition is x is greater than 0, y is greater than 0. Using these properties and formulas, we can solve exercise 2.3, isn't it? Let us first we will solve exercise 2.3. Later on we will see the solution of triangle, isn't it? Let us see question number first of exercise 3.3. Find the principal value of the following: sine inverse of 1 by 2. Let us solve this. Let sine inverse of 1 by 2 is equal to, suppose, x. Therefore 1 by 2 is equal to sine of x. That is sine x is equal to 1 by 2. Sine x is equal to, we know, sine of pi by 6. Since sine pi by 6 is equal to 1 by 2, we know. Value of sine 30 is 1 by 2, isn't it? Therefore sine get cancelled. X is equal to pi by 6. Now we have to see that this value lies between, because we know principal branch value of sine inverse is close interval minus pi by 2 to pi by 2. Also, that is minus 90 to 90, isn't it? Also, minus pi by 2 is less than pi by 6 is less than pi by 2. Means that is minus 90 is less than pi by 6 means 30 degree is less than 90 degree. This 30 degree lies between minus 90 to 90. Therefore, principal value of sine inverse 1 by 2 is equal to is pi by 6. Answer. In this way we can solve very simple question, isn't it? Remaining questions we will see in coming video.